Homeland security challenges are particular in the sense that they tend to appear deceptively simple, but in reality they are very complex. So for example, when we try to address an issue like migration here, often, what is considered as the challenge is the moment that someone is reaching our border, right? And we try to see how we can address, the resulting needs. But the problem is that this is a process that may have started many years and many, hundreds or thousands of kilometers away from that border. So what we try to do here is we try to provide a solution that allows us to understand how this process evolves over time and how does it reach the point where someone is actually coming at our border. The basic idea is that we now have an abundance of data that actually capture a variety of different social and economic conditions in the countries where migration originates from. And what we try to do is we try to use some deep learning techniques that would allow us to actually understand which of these parameters play more of a role in driving migration and how these migration patterns then can be manifested as a result of the variations of these parameters.
Deep learning capabilities have advanced tremendously over the last decade. They're revolutionizing a wide range of different sectors. We hear about this in the news all the time. What we want to do with this project is to bring some of those same capabilities to the DHS, specifically focused on leveraging deep learning to understand and predict migratory flows to the southern border. This is more than just an aggregate number. We are really seeking to identify when, where, and how many migrants are likely to cross the border at individual geographic locations, and even beyond that, model how we could mediate those flows through broad scope policies.
So my role in the project is mainly data preparation and model construction. So I work really closely with two undergraduate students who do a lot of the data cleaning and the data collection with both the census data and the satellite imagery. And then I take that data and I build the models around it that are predicting our migratory flows. So I think the really exciting part of this project is the integration of deep learning and satellite imagery. That's a really new direction in our field right now. A lot of the AI research that's being done is being done on benchmark data sets, but actually taking those models and applying them to real world data sets and real world problems is still kind of a very new and growing field. So being able to take this satellite imagery, a lot of people wouldn't believe would be able to do some of the predictions that it is doing. It's just a really cool thing to see it really play out.
A lot of my work revolves around the data collection part of it. So in collecting census data, we were extracting that from iPumps International, which is the largest database of microcensus data. So it involved pulling socioeconomic factors about Mexico and also migration variables, cleaning that data and formatting it in a way where it can be inputted into deep learning models. So that was really where I began on work for this project, and now I am replicating the analysis that was done to predict migration from Mexico to the US for the Northern Triangle countries.
We've integrated all of this also into a forward-facing website, which represents a technical proof. On this website, one of the really exciting things is that we've also begun to observe model behavior that is reflective of many qualitative theories of migration. And these theories are being learned by the model itself with no explicit code from us. So to put this another way, the model is capable, we're seeing, of inductively learning things that social scientists have been deductively testing for multiple academic generations. To give one discrete example of how this is working, in the current tool that's built on the deep learning model, if you increase income globally, that is across all of Mexico, you say that we're going to have a 5% increase in income, you see an overall decrease in the number of migratory flows. So the number of migrants we would estimate goes down. However, if you increase income in only predominantly poor rural communities, you actually see an increase in migration from those areas. This directly echoes extensive research indicating that in poor regions, there may be so few resources that individuals can't even afford to migrate. Thus, if we enacted policy to provision those individuals with additional funds, more people would actually choose to migrate than could do so before. So the model is observing this very complex relationship in the data, and those relationships are being manifest in what we're seeing today. So this is very exciting for us and something that we think that gives us real confidence that the model is being able to capture really these very complex relationships in ways that hasn't been done before.
This is a great environment in terms of knowledge discovery from an academic standpoint, because it allows us to bring together different disciplines, computer science, data science, and some social science skill sets as well, to address a very, very complex problem as the one that we are addressing here. And what we try to do is we try to prepare a tool that will actually allow us to actually better predict how these variations in migration patterns may occur over time, and use this information to try to allocate our resources optimally so we can address the needs of the migrants as they arrive at the border. We can address our national needs as well.
So we have designed the interface to be as easy and simple to the user as possible. So a lot of people don't really know how to work with satellite imagery, and that's totally fine. So on the back end, we do a lot of the work for them in order, changing variables and the census data that they'll actually be able to interact with. So the user never sees anything confusing. They only see super straightforward things like, changing economic variables. And then we present things in a really usable way so that, in a mission scenario, they can really easily go in and they can look at a very obvious and friendly user interface. So all of the deep learning and the hard stuff is left to us, and we try to make things as simple as possible for the end user.
Predicting cross-border migration has a lot of implications for enhanced national security. It could be applied to more efficient allocation and deployment of agency resources at the border, or other DHS operations that focus on that cross-border movement. So, for instance, monitoring drug trafficking routes. So any issue that is centered around that border, this can be applied.
The primary incentive here is being able to better understand what is driving individuals to migrate, how policies might mediate that, and also have a much better tactical and strategic understanding of where these flows are likely to occur on the southern border.
We are addressing an operational need of the agency, and that operational need is to actually be able to allocate resources for forthcoming events as opposed to trying to address crises as they may have already happened at the border. So our tool is going to have the ability to predict to a certain extent how migratory patterns may change, may vary over time, and DHS hopefully will be able to use that information to plan for its resource allocation.